Hi, this is Jeff Heaton. This is a quick video update on my Kaggle competition that's going on this semester. This ends November 11th, 2019. So I released a Google Notebook, which I have linked at the description of this. It gives you some starter code. It's basically starter code that I took from another Kaggle competition and modified real quick just to work for my Kaggle competition. Very common technique in Kaggle. Always borrow code from other sources, and I give you a link to the original code as well. If we look at the leaderboard, there's a number of students that have now broken into the 0.57 and 5.6 range. The code that I released gets you right in about the 0.57 or so range. So let me show you this starter code, because it's pretty good starter code for this. Now my competition is very similar to the Kaggle Quora competition. Quora was where you take two sentences and you say if they're asking the same thing, so two questions. Mine takes two sentences, and you're supposed to determine if they're from the same type of Wikipedia article. So very similar in terms of the input. You have four inputs, essentially. You have the ID is the first one, the two sentences are the second and third, and then you also have the target, which is 0 or 1. Are they from the same source or not? This is a starter notebook that somebody created on the question pairs one for Quora, and if you notice it's 0.34. Now you won't get that. That's a log loss. You won't get that in my competition unless you really modify the heck out of it. You might be able to get it that low. We'll see where people finally end up. And mine's a pretty short run Kaggle, so this is why I'm giving you some starter code to help. Now, I want to go through this code because it is kind of complicated compared to some of the stuff that we've maybe seen in the class, and just explain what the parts are. So here you have a random seed, 1.2357. By the way, if you modify this code to work with my class, just use my notebook. I've already modified it. This code's from about 2 years ago, so this line in sklearn is now obsolete. You need to replace that with the current I forget where it comes from. I think it comes from model selection rather than cross-validation now. But they changed that a little bit. Kind of an annoying breaking change on their part, but nonetheless, that is sklearn. This is the random seed. So this is 1, 2, 3, 5, 7. So this tries to give you consistent results as you run this. You can change that and you'll get different results. I don't know that I would spend time trying to tune the seed. The rounds, this is how many XGBoost. And this uses XGBoost. XGBoost was really popular with Kaggle when this competition came out. You might try LightGBM. That has kind of stolen XGBoost's throne to some degree. But it would require a little modification. You can try deep learning like we have in the class as well. But this is how many rounds of XGB it's going to go through. There's no early stopping on this. This is a very simple solution. If you do early stopping, you do cross-validation, you'll probably improve your score. This is a little function that he wrote, that the author wrote. I'm not sure it's a he or a she. I think it's a he. And it essentially prints out, and it does a really quick train test split. This train test split is 20%, I believe, and 0.2. This is really just to give you a good estimate of how well you're going to do with this one. And when I was testing it with my Kaggle, you were actually getting a little better score even than what this estimated. Now the point here is, too, you are not using the entire training set. So you might want to experiment around with this. Find how many rounds until you're starting to overfit. Lock it to that and use the whole training set. You won't have an estimate of your error, but now you're training on the whole thing. And that sometimes gives you a little bit of a lift in Kaggle. That's another common technique. This is just converting it into XGBoost format. This watch list says that we're watching the train and the eval. I'll show you what that looks like in a moment. And then we fire it off. We do the XGBoost train with the rounds and with these parameters. And I'll show you the parameters for XGBoost in a moment. That's a huge part of XGBoost. You may want to use the Bayesian optimization to help you pick these hyperparameters, because these are tuned for Cora, not for my competition. This is a little predictor method to be called. And I'll show you another thing too. He's defining all these functions at the top level. Then he creates a main and also defines functions inside a main. I don't really like that technique a lot, but that's what he does. This feature map here is used for importance, to tell you which features are the most important, because you're going to probably start adding your own features onto this. And you'll want to know if your features are helping or not. So these are the parameters that he chose. These are tuned for Cora. You have binary, logistic, and log loss. You want to keep those two the same. Eta is like your learning rate. Max depth is how deep you want your trees to go. Tuning these two will probably help you. You might want to use Bayesian on that to optimize those. Silent, you'll probably want to leave at 1. These are the two training files. Now you'll need to modify these, or just use my already modified code to point at wherever your path is. Now with the weighting here that we have, I suggest not using the weighting, because weighting is used, or balancing is used when you want, and I think this is used as part of the balancing. Like I said, I did not write this code, so the balancing deals with the fact that in the Cora question pairs, the training and the leaderboard sets were not balanced. There were a different number of positives in the validation set, or a different distribution of positives. Because of that, balancing will help your score. In mine, there's 50-50 of each, so balancing will not help you. This train QS that he creates, now I showed you how to use Spacey to separate the two sentences into words. Spacey takes a whole lot more time. This is a primitive, just split on spaces, and doesn't work as well, but it gets you decent results, and it's fast as anything. It takes maybe 5 minutes to run this whole thing. Now this you would have to change. In Cora it was called question 1 and question 2, and mine is sentence 1 and sentence 2. You might also want to pass in the test, because this is building frequency maps of the words, so very uncommon words might be more highly weighted. So you might want to put the test set into here too. I usually would put the test set, but you see they're basically splitting it on spaces and counting them. That is purely so that more rare words count for more. It's called TF-IDF. Then stops, they're doing something with the stop words to eliminate those. This might be a little complicated, the way they do this word shares, if you don't understand essentially what they are doing. They are essentially packing about 5 features, all related to word sharing between the two sentences, into a colon-delimited string that they're going to break apart later. So if it doesn't find anything, then these are going to be all zeros. So these are 5 features concatenated together into a single string. The reason they do that is because the apply function that you use on pandas can only return 1 feature at a time. So they return a packed feature and then unpack it in a moment. So the first time you see that, that's a little weird. But just to explain to you what that is, because you may want to add some features to this. If you add features that deal with sharing between the two questions, you probably want to just add them onto here. It'll be faster. So they count the number of stops they remove the stops using intersection of steps, sets, I should say. They count the number of shared words, and basically this is where they create all these 5 features that are packed together. So there's the TF-IDF score. So that's how common these are. That's where the weightings were used earlier. The count, share, and number of stops in question 1, number of stops in question 2. I'll tell you right now, for this competition that I'm doing, I don't think the stops will be nearly as important as they were in Quora. So be aware of that. Is if you think about it, if you're looking at if two questions are the same thing, is the sky blue? Is the color of the sky blue? I mean, they have similar stop word structures. Whereas I'm just picking two random questions or two random sentences from Wikipedia. So then what they do, this is also a little confusing if you haven't seen it before. They are concatenating the test and the train sets together. And what that basically does is that lets them do all the feature transformations on one unified set. And that unified set then, they don't have to write two of these, because normally you have to encode your test, you have to encode your train. So this combines them together. They're marrying them to divorce them later. They're going to combine them and then separate them. They create the word shares. So this is the combined feature. That combined feature goes into a temporary feature called word shares. It's going to be all those colon separated ones together. Then they create the X data frame. And this is where they split it apart. All of these first 5 come from the colon one that they put together. See, they're splitting it on the colon. So that breaks all of these apart. Now, why didn't they just do them all separately? Because you gain a lot of efficiency by separating out the words up here. And word separation can be expensive. You could experiment, too, with using spacey up here, but it's going to take much, much longer. It's all a trade-off in these Kaggles where you don't have a lot of time. It's a hackathon. Then he engineers a bunch of other features here, looking at the lengths and the difference of the lengths and other things like that. Average word length, all kinds of features. Not a whole lot, though. This is it. This is a very short solution. He gets the feature names. He's going to need that for importance reporting. This is very important here, this code. Remember how we concatenated train and test together? This is where they separate it back out. So that was a convenience, but it makes the code a little confusing. When you're first looking at this, you may wonder what the heck is going on. Del, he deletes a lot of these ones that he doesn't need anymore. He was worried about memory because Quora is much, much bigger than what I gave you. This section here is balancing. It's set to 1. The code that I gave you, I just removed this. This does not help you at all. It'll hurt you badly, actually, with my competition, because this P value that he has here, you have to tune that and figure out what your balance is between the train and test on Kaggle, the leaderboard. Mine are evenly balanced, so this will do nothing for you. I'm not going to explain balancing here. I might do a video on that later because it comes up a lot in Kaggle. Balancing is one of the big Kaggle hints. And then he basically trains it and produces feature importance. So this is what it looked like for him. You'll see this when you run mine. You'll see the train log loss and the eval. The eval should be approximately what you're going to get on the leaderboard. Now this is running for Quora, so yours will look different. And then you should also get a feature importance plot. And you can see that under output, I believe. Running it on, yeah, you'll get something like this. So this is just a quick start on how you could get going on really any natural language processing thing on Kaggle, or also mine as well. So this will give you a quick start. I would suggest adding some more features to this. He gives you a section in code, and I left it in, where at the end he says, add your features here. So the ways to improve this: tune the hyperparameters, use the entire training set, add your own features. Those are the things I would start with this.